Hi everyone, I'm Dr. Surjit Singh. Today we'll talk about the Leetcode problem, insert interval. Let us begin. We are given a list of non-overlapping sorted intervals. We are to insert a given interval so that the properties of the list are not disturbed. In the first step, we find the position where we will insert the new interval so that starting times of the intervals remain in the ascending order. Naturally, binary search for the insertion position is faster than the linear search as the list is sorted. Consider the given sorted list of intervals and a new interval to be inserted in it. Insertion position is the first element of the list whose start time is greater than or equal to start time of the new interval. We fix the initial search boundaries for our insertion position between the beginning of the list to a new entry position next to the end of the list. In order to narrow down the gap between the left and the right boundaries, we initiate a loop that goes on as long as left is less than right. Each time we find the midpoint of the two boundaries. Start of the new interval is less than start of the mid interval, so we shift right fence to mid. In the next iteration, mid becomes 1. This time, the if condition is false and we move left to mid plus 1. Now that left and right are equal, the while loop terminates and left becomes the position where we insert the new interval in the list. Note that if the given list of intervals is empty, both left and right are 0 and the while loop is skipped. Pause is 0 and the new interval is the only entry in the final list. After inserting the new interval in the list, we still need to handle the overlapping of the new interval with its neighbors. List is fully sorted with respect to the start values of all intervals. Depending upon its end value, the new interval may overlap with a few intervals to its right. But first we check if the previous interval is present and the end value of the previous interval overlaps with start of this interval. If this happens, we decrease pause by 1. Sorted structure of the list ensures that new interval cannot overlap with more than one intervals present to its left. Now all intervals before pause are properly placed and we can start merging interval at pause with the intervals to its right that overlap with it. In a loop, we will repeatedly perform the merging process as long as next interval is present and end value of interval at pause is greater than or equal to start of the next interval. The two intervals in our example do overlap. So we replace the end of interval at pause with larger of the two end values and it becomes 9. Next interval has now become superfluous and we pop it out. In the next iteration also interval 1 overlaps with interval 2, but this time end of interval 1 is already higher than end of interval 2, so we do not change it but simply pop out the interval next to pause. Overlap exists even if the end of one interval is equal to the start of another. So interval 1 becomes 310 and we pop out 910. Now that the interval at position 1 does not overlap with the interval next to it, we come out of the loop and return the final result of the intervals as the answer. Even when binary search has time complexity of the order of log of n, the merging process is linear and in the worst case, time complexity is of the order of n. Insertion and deletion in a list is very slow as we have to move the list components sequentially to remove an element or to make room for insertion. We could convert list to a linked list in the beginning. Insertion and deletion take place in a constant time in a linked list and the processing becomes faster. We have performed all changes in the original list without involving an extra list, so space complexity is constant. If we use linked list, processing becomes faster, but space complexity becomes n for saving the linked list. I hope you liked the video. Thank you for your time. Please stay tuned for more such interesting videos.